Good day to you, students. How are you doing? Today, we'll be dealing with chapter 16, Magnetism. Let's start the class. Permanent magnet. Let's drag the words into the correct boxes to be able to define what a permanent magnet is. A compass needle is like a bar magnet. When it is free to rotate, it starts to point north-south. One end points north, which is the magnetic north pole. The other end is the magnetic south pole. When two magnets are brought close together, there is a force between them. The north pole of one will attract the south pole of the other. Two north poles or south poles will repel each other. This is summarized as like poles repel and unlike poles attract. Looking at this last statement is typically telling us the law governing electromagnetism. When you bring two magnets together, probably on the south and south, on two south poles, they are not going to what? Attract, they are going to repel. The same thing for the north to north, but when it is north and what? South, they are going to what? Attract. That is what? Unlike poles, which will then what? Attract. Let's check. Alright. So let's deal with magnetic materials. We have to fill in the missing words. A compass needle is a permanent magnet. A magnetic material is also called ferrite. Most magnetic material contain iron. This is why they are known as ferrous materials. Other magnetic materials include cobalt and nickel. If a substance contains iron, this is not a guarantee that it will be magnetic. Stainless steel contains a lot of iron, but magnets will not stick to it. Magnetic materials may be classified as hard or soft. A soft magnetic material can be magnetized and demagnetized easily. Let's check. Correct. Now, magnetization. Magnetic materials are usually in an unmagnetized state and they must be magnetized. Two methods of doing magnetization are listed below. A. A piece of the material may be stroked with a permanent magnet. By stroking it consistently from one end to the other, it becomes magnetized. B. You have to place the material in a strong magnetic field as produced by an electromagnet. An electromagnet is a coil of wire which is connected to a battery or power supply so that a steady direct current flows through it. This produces a magnetic field inside the coil, and this field magnetizes the material. Now, let's deal with this question. All these are methods of demagnetizing a material, except now exposing the material to air. Yes, But for all other options, let's see how it goes. Place the magnet in a field of an electromagnet that is connected to an alternating current supply. That is one of how to what? Demagnetize a material. Hit the magnet, yes, to demagnetize the material. Arming the magnet also to demagnetize the material. So the odd one out now is exposing the material to air. Okay, we move on. Now, induced magnetism. Let's get to the definition of induced magnetism by dragging the words into the correct boxes. Permanent magnets are made of hard magnetic materials whose magnetism does not get used up. A permanent magnet can also attract other unmagnetized magnetic materials. For instance, a bar magnet can attract steel pins or paper clips, and a fridge magnet can stick to the steel door of the fridge. How induced magnetism is produced is that steel pins are made of a magnetic material. When the north pole of a permanent magnet is brought close to a pin, the pin is attracted. The attraction tells us that the end of the pin nearest the magnetic pole must be a magnetic south pole, which is referred to as induced magnetism. Let's check. That is awesome. Now, magnetic field. You are also to drag the words into the correct boxes to be able to define magnetic field. A magnet affects any piece of magnetic material that is nearby. There is a magnetic field around the magnet. To represent the magnetic field of a single bar magnet, magnetic field lines is used. The patterns show two things about the magnetic field lines. They are direction and strength. Field lines come in the north pole and go into the south poles. Let's check. That's awesome. Now, looking at these two diagrams, we are still discussing about magnetic field. If you look at the one on the left, field lines represent the magnetic field around what? A bar magnet. The magnetic field pattern of a bar magnet is shown up by what? Iron filings. And around the two poles, where what? Where the field is strongest. If you look at the other diagram on the right, you have A, B, and C. You can see that for the North Pole side, the direction on the north is radially directed outwards, while the direction on the south is radially directed inwards. For B now, you can see the attraction between the north and the south poles of the two what? Magnets. That is what? An attraction. While for the C, you can see that the north is facing each other. That is to tell us the repulsion between two what? Bar magnets. Now, how do we plot field lines? All right, so we have to fill in the missing words. Place a magnet under a stiff sheet of plain paper or clear plastic. All right. Sprinkle filings over the paper or plastic. Tap the paper or plastic to allow the filings to move slightly so that they line up in the field. An alternating method is to use a copper wire. No, it's to use a plotting compass. When a plotting compass is placed, a magnetic field its needle turns to indicate the direction of the field. Let's check. That's correct. Now, let's deal with electromagnets. You are supposed to drag the words into the correct boxes. Using magnetic materials is the only way of making a magnet. An alternative method is to use an electromagnet. A typical electromagnet is made from a coil of copper wire. Coils like this is called solenoid. When a current flows through the wire, there is a magnetic field around the coil. Magnetic field around the solenoid is similar to that of a bar magnet. One end is the North Pole and the other end is the South Pole. So let's check. Now we are still defining electromagnet. There are three ways to increase the strength of an electromagnet. This involves increasing the current flowing through it, increasing the number of turns of wire on the coil, and the addition of a soft iron core. So let's check. All right. Now let's deal with this past question. A permanent magnet is placed close to a bar of soft iron PQ. What happens? Now let's look at the first option. The poles of the magnet are reversed. That is not true. Now P becomes the south pole. Check it very well. When you place two magnets together, if they are to attract or be beside, that means the north side of one will face the what? South side of the what? of the other. So where we have P now, that is the what? The south pole for the second magnet on the what? Right. So that shows that P becomes the south pole. Let's take the other option. PQ does not become magnetized. That is a lie. It will become what? It can become demagnetized since it is a permanent magnet. P becomes the north pole. That is what? False. So the correct answer here is that P becomes the south pole. Let's check. That's correct. Now, looking at this metal from this diagram, a student wishes to use a magnetizing core to make a permanent magnet from a piece of metal. Which metal should she use? Now, for the production of electromagnets, for instance, solenoid, what type of metal do you think is in use? That is what? Copper. So for this type of diagram also, for us to be able to make our permanent magnet, we are going to use what? Copper. So copper is the answer. So we check. That is it. Now, another question. An electromagnet is used to separate magnetic materials from non-magnetic materials. Why is steel unsuitable as the core of the what? Electromagnet? Is it a good conductor of electricity? No. It has a high density? No. It has a high thermal capacity? No. It forms a permanent magnet? Yes. So a permanent magnet can be used to separate magnetic materials from what? Non-magnetic materials. So that is the major reason. So that is it. Now, let's choose the correct statement before we wrap it up for the day. When two magnets are brought close to each other, there is no force between them. That is false. When two magnets are brought close to each other, there will be a force of either attraction or repulsion between them. When two magnets are brought close to each other, unlike poles repel, while like poles attract. That is false. Okay? When you bring two nuts and nuts together, involving two bar magnets, they are going to what? Repel. And if it were to be south and south pole, they are going to what? Repel. It is only north and the south pole that can what? Attract. So let's look at this third statement. When two bar magnets are brought close to each other, like poles do what? They repel. That's true. And unlike poles, attract. That is also true. So the third statement is what? The correct statement. So with this, we've come to the end of this class. Do well to join our website www.edubbey.com for more of our interactive notes and what? Classes. All right? Bye for now.